AI models can be easier to build or easier to deploy, but rarely both. How can we build advanced AI models using only SQL? How do we export these models in a portable way? And how can we run a production-grade real-time ML API without advanced code or complex cloud work? You'll see all that and more in today's tutorial. Here's how it's going to work. We'll take a SQL-based data warehouse, in our case BigQuery, and employ it to build a BQML model. In essence, BQML is a SQL-based framework for model creation and evaluation. And for a real-time API that works like magic, we're exporting it to Vertex AI Endpoints. Sounds exciting, right? Well, the goodies don't end there. We'll also be armed with features like cloud logging and monitoring, making our solution inherently dynamic and highly observable. This results in high performance, opening up interaction between our endpoints and several applications, be it your everyday web application or an ML pipeline. Believe it or not, creating a robust production grade API doesn't require magic. All you need is a Google Cloud account to fuel the whole system, and of course, your basic SQL know how. With the roadmap outlined, let's put pedal to the metal and start setting our system up in the console. Our journey starts at BigQuery. We are drawing data from the BigQuery Public Datasets program, saving us mammoth work in terms of data modeling and preparation. Let's dive into our query interface, roll up our sleeves, and create a BQML model. We'll kick things off by creating a dataset. Let's christen it Demonstration and set it in the US Central region. Within our freshly minted demonstration dataset, we'll conjure a logistic model. Did you notice how the model type is logistic within the model options? This means we'll be applying regression to predict financial defaults for the following month. It's incredible that a few extra keywords in standard SQL, like the model keyword, can wield such power. No mind-boggling feature engineering is happening here, folks. Just simple addition of relevant features to our model and ensuring our label columns are up to snuff. With the model training underway, we shouldn't be waiting long. Once it's complete, we can delve into the training options, peruse the loss curve over our training iterations, understand the durations and our learning rate, and review evaluations such as precision recall curves and a confusion matrix. Let's pull back the curtain and glance at our dataset. Looks like we're working with around 3,000 values. As part of the training, an impressive 2,300 data points were used, with a measured stash of around 600 set aside for evaluation. Our next move is to export our model, but first, it's vital we establish a home for it in Google Cloud Storage. You should be aware that managing these cloud storage buckets is also achievable via the standard cloud storage page. We crafted ours using a handy shortcut, but it's equally manageable right here. Suppose we fancy deleting this bucket to create a regional alternative for cost efficiency. We're free to action that right here. Once you're all set up, don't hesitate to hit submit. Our model's journey to success won't be a long wait. Soon it will find its new home in our bucket. And as soon as the model is ready and exported to our selected bucket, we can realign our focus onto Vertex AI. We'll be serving our exported model as an API. Engage import mode and welcome in a new model. For the framework, TensorFlow is our go-to. A modern version like 2.12 should serve us quite well. We'll need to divulge the path to the model's location too. For our saved model, we have this effective protobuf format, and we just need to pinpoint the folder it resides in. The rest, we can leave it as is or just follow the defaults before finalizing our model import. Here's the crucial part: efficiently managing the model and setting it off for deployment. Now, buckle up for this critical stint of porting our BQML model, which is now lounging in Vertex AI's model registry, for deployment to a real Vertex AI endpoint. To really pull this off, we need to scoot over to the Deployed Models page and initiate a deployment to the endpoint. We'll christen it with a name. An essential factor to consider here is the machine type. An N1 standard 4 should suffice for our model type. The great part? We can enjoy both logging and explainability features, and we're at liberty to host multiple models on a single endpoint. Monitoring is a fantastic attribute, providing constant oversight to ensure there's no training serving skew or unanticipated prediction drift. This is a delightful facet of the MLOps lifecycle that is smoothly managed if you enable this attribute. Shall we opt for a simple deployment and proceed? Bear with us for about 10 minutes. It will be worth the wait. Once that model is up and running, we can put it through its paces. This user interface provides a convenient way to test, but testing can also be done using the Python SDK or curl calls. Let's grab an example request, providing specific details. The predicted results indicates non-default, with a solid 81 to 82% probability, along with some useful metadata at our disposal. So there you have it. We've successfully got a real-time HTTP API up and running from our BQML SQL-based model, all in a production-grade manner, almost effortlessly, with integral facilities like cloud operations integrated for logging and monitoring, drift protection, and training serving skew protection. We hope this tutorial was enlightening for you, and as is our tradition, you'll find the SQL code and the diagram file included in the video description. Thank you for your time, and please enjoy responsibly.